Alright, this is the second video for the review. We left off at number 17. For numbers 13, 14, 15, we're going to be trying to combine, well, for numbers 13, we're multiplying radicals. When I have 2 square root 6 times the square root of 5 plus the square root of 6, I can't combine these two because they're not like radicals. In the same way that with like terms, I can add up 5x and 3x together to get 8x. For like radicals, I need to have the same index. So if it was like the cube root, I need to be adding up some cube root here. And I need to have the same radicand, like the same value inside the radical. So if this was the cube root of 5 plus 4 cube root of 5, this is like a single cube root of 5. So together this would be 5 cube root of 5. So when I multiply here, this is going to look like 2 times the square root. I'm going to write these inside together. Square root of 6 times 5, or 2 square root 30 plus, and then we got 2 times the square root of 6, 2 square root of 6 times 6, or 2 square root 30 plus 2 square root 36. The square root of 36 is 6, so this looks like 2 square root 30 plus 2 times 6, or 2 square root 30 plus 12. For number 14, again, we talked about how we could combine like radicals. To do this, I would need to simplify the square root of 27. Some people will make a factor tree and look at the prime factorization of 27. I've shown you guys where you can write out factors and look for a perfect square. So it's like -2 times the square root of 9 times 3, which if you want to write like -2 square root 9 times the square root of 3, that works as well. -3 square root 3, I can't simplify any more from there. And then I'm adding 2 square root 9 times the square root of 6. So this is -6 square root 3 minus 3 square root 3 plus 2 times the square root of 9, which is going to be 6, square root 6. I can combine -6 square root 3 with the -3 square root 3, or take away 3 square root 3 from that to get -9 square root 3 plus 6 square root 6. The same thing is happening here with number 15. -2 square root 3. I can't simplify that more. This is going to be plus 2 square root 4 times the square root of 6 minus 2 square root 9 times the square root of 6. So I get -2 square root 3 plus 4 square root 6 minus 6 square root 6 to get -2 square root 3 minus 2 square root 6. All right, for number 16, I need to multiply by the conjugate. So if we have like a plus the square root of b, if I multiply a plus the square root of b times a minus the square root of b, I'm going to end up with a squared minus b. And in this example here, I'm going to multiply both the numerator and the denominator by -3 minus 2 square root 3 and -3 minus 2 square root 3. -3 times -3 is going to be a positive 9. And then I have -3 times a -2 square root 3 is going to be plus 6 square root 3. 2 square root 3 times negative 3 is going to be minus 6 square root 3. And 2 square root 3 times negative 2 square root 3 is going to be minus 4 square root of 9. I'm going to be left over with 9 minus 4 times 3, or 9 minus 12 to get negative 3. So in my denominator, I'm left with negative 3. In the numerator, I'm multiplying negative 12, right? Negative 4 times the negative 3. And then I'm multiplying 4 times the negative 2 square root 3, so minus 8 square root 3. If you look at the answer, they're showing us that it's going to be positive 12 plus 8 square root 3 over 3. We could factor out a negative 1 from each of these and write that like 12 plus 8 square root 3 over 3. For number 17, we're trying to factor the quadratics. We're looking for two numbers that multiply to a negative 21. And the same two numbers have a sum of negative 4. If we look at the example here, when we're looking at that sum, some people were describing like the larger of the two numbers, understanding that there had to be an x plus and an x minus. That we want to be taking away or subtracting the larger of the two numbers that we're looking for, the factors here. So in these examples, 1 and 21, 3 and 7, I would rewrite this like negative 7 times 3 and negative 21 times 1. And then here, x plus 3 times x minus 7 is going to get, when I multiply those, I get x squared minus 4x minus 21. In number 18, the same rules are going to apply for the work we do with quadratics with factoring, whether we write this in terms of x or a. Still two numbers that multiply to a positive 12 have a sum of negative 7. So you're going to be subtracting for both of these. This is going to be negative 3 times negative 4. So x minus 4 times x minus 3. So in these examples, they're strictly asking us to factor. If they're asking us to solve and you factor, you need to set each factor equal to 0. For number 19, they're asking us to complete the square. The first thing I would do is subtract 27 on both sides of the equation. I'm left with x squared plus 12x equals negative 20. To complete the square, we want to write this in the form of something squared. So I'm going to take the constant here for the linear term, 12. Not constant, sorry, coefficient for the linear term, or b, divide it by 2. Then I'm going to square that for 36. And I'm going to add 36 on both sides of the equation. Some people were having a hard time with the review trying to make the jump that this is going to be 6 or x plus 6 squared. If it helps you to factor it and then write it as something squared, like the two numbers that multiply to 36 that have a sum of 12 are going to be 6 and 6. So I can write this as x plus 6 squared equals 16. At this point, I'm going to take the square root of both sides of the equation. X plus 6 equals plus or minus 4. Then I'm going to subtract 6 on both sides. X equals negative 6 plus or minus 4. For number 20, in the quadratic formula, I'm going to give you guys the quadratic formula. I'm not expecting you guys to memorize that part. So I told the class too that you guys could bring in a cheat sheet. You don't have to worry about writing that part of this down. It's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the a, b, and c come from our quadratics in the standard form. Ax squared plus bx plus c. So if I have 4n squared plus 8 equals negative 12n, I need to subtract 12n on both sides of the equation. 4n squared minus 12n plus 8 equals 0. A equals 4. B equals negative 12. C equals 8. So when they ask for a negative b, it's going to be negative the negative 12 plus or minus the square root of negative 12 squared minus 4 times 4 times 8 divided by 2 times 4. So I get 12 plus or minus the square root of 144 minus 128 divided by 8. 12 plus or minus the square root of 16 over 8, or 12 plus or minus 4 over 8. This is showing me two different numbers, two different solutions here. 12 plus 4 divided by 8 and 12 minus 4 divided by 8. So 12 plus 4 over 8 is going to equal 16 over 8, or 2. So one of my answers is x equals 2. And 12 minus 4 over 8 equals 8 over 8. I get x equals 1. So for numbers 21, 22, and 23, I'm going to use the discriminant. It's b squared minus 4ac. When this is positive, I'm going to have two real solutions. When it's 0, I'm going to have one real solution. And when it's negative, I'm going to have no real solutions. There'll be two imaginary solutions. Just like before with the quadratic formula, this comes from our equation in the form ax squared plus bx plus c equals 0. So I would need to add 4 on both sides of the equation to get negative 7 x squared plus 8x minus 3 equals 0. Or 8 squared minus 4 times negative 7 times negative 3. I get 64 minus 12 times 7 is going to be 184. So this is equal to negative 20. The fact that it's a negative number tells me that this is going to be no real solutions. For number 22, just like the one before, I'm going to need to subtract on both sides of the equation. Negative 7x squared minus 3x. This is going to be plus 4 equals 0. So I get negative 3 squared minus 4 times negative 7 times 4. So negative 3 squared is going to be 9. 4 times 4 is 16. So 16 times 7 is going to be 70 plus 42. So I get 9 plus 112, or 121. This is going to be two real solutions. And for number 23, I'm going to add 2 on both sides of the equation to get negative 5x squared plus 10x minus 5 equals 0. A equals negative 5, B equals 10, C equals 5, or negative 5. So I get 10 squared minus 4 times negative 5 times negative 5. Or 100 minus 100 is going to be 0, which is going to be one real solution. For number 24, we're going to be solving the equation here. To do the inverse or undo the square root, we're going to square both sides of the equation. I'm going to show you how to solve it by factoring. You could solve it by completing the square. You could solve the quadratic that we're going to see here with the quadratic formula. I just personally think it's easier to factor at this point for this problem. Like I said a second ago, I'm going to square this. When I square the square root, I'm left with 36 minus 5x is equal to x squared. I have an easier time when I'm factoring working with a positive x squared. So I'm going to subtract 36 and add 5x on both sides. So I get 0 is equal to x squared plus 5x minus 36. So I'm looking for two numbers that multiply to 36, and the two numbers sum is going to be a positive 5. So it's going to look like x plus 9 times x minus 4. Now each of these are being set equal to 0, so they can solve for the factors. So I get x equals 9 and x equals 4. For the next, For the next 5 questions, it's important to look at the order in which the operations are happening, and make sure that for a lot of these, when they have more than one term, we're using parentheses. So when they ask us for f minus g of t, this is not saying to multiply f minus g times t. You could rewrite this like f of t minus g of t. So f of t is t plus 1. And I'm taking away t squared plus 3. Some people talk about the subtraction here is it's going to change the sign of each term. I think with the practice we do with distributing, that it's easier for me to explain to students that this is a negative 1, and I'm multiplying the t squared by the negative 1 and 3 times the negative 1 to get t plus 1 minus t squared minus 3. I have negative 3 and the plus 1 is like terms. If I was going to write this in standard form, it would look like negative t squared plus t minus 2. You could also write it like t minus t squared minus 2. That would be fine. For number 26, I want g over f. So I'm dividing. G is 2n plus 1. And I'm dividing this by 4n plus 5. A lot of people have made mistakes in the past by trying to simplify where they can't. You can't divide each side by n. You can't divide each side by 5. We just want to write this function as 2n plus 5 over 4n plus 5. This is maybe too easy of an example for what we're being asked to do with the composite function. But when they have g of h of n, this looks like g of h of n. And now g of n takes whatever the input is, in this case it's the h of n, and then subtracts 2. And h of n is n cubed minus n minus 2, and that would be my final answer. For number 28, we are multiplying the two functions, and our input is 4. Now, there's nothing that says you can't go through, write 2x plus 3, x minus 1, expand these, multiply 2x times x and 2x times 1. However, my advice is it'll be much easier to work on this by finding g of 4, f of 4. G of 4 was going to be 2 times 4 plus 3, or 11. G of 4 is going to be 4 minus 1. And then for number 29, we're adding the two functions together, but it's going to be negative 2 times g of negative 4 plus h of negative 4. So negative 2 times negative 4 squared plus 5 times negative 4. And we're multiplying this function by the negative 2. Negative 2 times 16 minus 20. Sorry, that doesn't look like a parenthesis. 16 minus 20 is going to be negative 4. I get a positive 8. And then h of negative 4 is going to look like we're adding 4 times the negative 4 minus 4, or negative 16 minus 4. We're going to take away 20 to get negative 12. For number 30, we're being For number 30, we're being asked to find the inverse of the function. So the first thing to do is to change the g of x to y. Actually, I'm going to write this like y is equal to 2x to the 5th minus 1. And then we're going to interchange x and y. So instead of writing it like y, it'll be x equals 2 times y to the 5th minus 1. At this point, I would need to add 1 on both sides of my equation. So I get x minus 1 equals 2y raised to the 5th. At this point, I should divide both sides by 2. X minus 1 over 2 is equal to y to the 5th. And to undo or find the inverse of raising it to the 5th power, we're going to take the 5th root. Now make sure if you have a fraction like this example here, that you're drawing the radical large enough so that we can see that both the numerator and the denominator are inside of the radical. So I can say that the 5th root of x minus 1 over 2 is equal to y. I'm almost done with this example. I would need to go through, I need to write, instead of y, this as a function, and we're going to write it as the inverse of x is equal to the 5th root of x minus 1 over 2. Okay, our last function is looking at 3 to the x. So when I introduced this topic, we were talking about tables. At 0, this is going to be 3 to the 0, or 1. When x is equal to 1, y is going to be 3 to the 1st, or 3. At 2, it's going to be 3 squared, for 9. For a cube, this is going to be 3 to the 3rd, or 27. And so looking at these values, the x values are here, so we should have this match up in our x-axis, and our y values are here. We're trying to look at the ordered pairs. I think almost all of these have 0, 1 as one of the points. But the next one at 1, this should be equal to 3. Which can be a little difficult. And then at 2, this is going to be equal to 9. fact that this is decreasing and showing decay, that means that this is not going to be the right answer. At 2, right, like the x equals 2, this looks like it's going to be 4. So D is not an option. This looks like we could say at 1, it's approximately 3, but at 2, so like it's somewhere over here, that's going to be too large. And so we're saying at 0, it's 1. And then at 3, or sorry, at 2, this is going to be 9. So this is going to be our answer here. All right, if you have any questions about the exam, let me know. Email me. It's going to start at 3:30. And if you guys could please not forget to bring a calculator, that would be fantastic. Have a good day.